GDG Porto for choosing my submission. I hope I'm going to be of high quality as your DevFest. And secondly, I would like to ask you a little favor. And there is a resolution I decided to start doing this here. I need to do a little video of you, if you'd like to, saying ciao Mitch, ciao Carlo. There's two friends of mine that are from Google. One is in San Francisco and the other one is in Italy. And if you want to turn up a little bit the lights so I can do a little video. If you all agree, do you all agree to do that? Yes. Okay, thanks a lot. Well, I'm going to take that part because that one is a little bit empty. So we're going to do a test. I'm going to do ciao Mitch, ciao Luca, sorry. So, ready? Ciao Mitch. You said that? So I think he is the one who will win in the prize. So on my three, ciao Mitch, ciao Luca. Ciao Mitch, ciao Luca. Awesome. Thanks a lot. Thank you very much. Back a little bit. I'm going to do a little bit of background, rephrasing a little bit the GDG keynote that they did and how we started our little lab. We got inspired by GDG. I used to be, and I'm still an organizer in Greece, but not so often because I'm getting old. And to do a GDG, you need to be from 25 to 35. After that, you're starting getting old. And you're not losing enthusiasm, but you're losing your organism. And yeah, we ran GDG in Greece for about 5-6 years. I ran personally. And after that, we decided that the community-oriented work is the best work you can do because you have diversity. We heard earlier on Ines saying about women. We have about 65% women in our team, not in GDG, in our team. And we are sharing things as a community. And that's why we go one step ahead. I'm doing these little excursus of my background because, as I told you, my team is basically based on those principles and theories. And we started 4 years ago, and we started with a really nice project powered by Google. And it was a project for developing an app for astronauts. Today is my first day, is my first time that I'm publicly sharing with you our achievements. And because it's really early in the morning for me as well, and thank you for coming over this morning on Saturday. If you see me a little bit on a truck or outside of truck, just encourage me because it's really my first time that I'm talking about the achievement we did. And 4 years to try to concise them in 30 minutes of processes and procedures, it's not so easy. So today we're going to talk about how we change our perspective. We are developers. You are developers, I guess. How many of you are developers? Okay. Any graphic designer, any designer? Okay. Software engineers? Okay. We got all the range that this talk is addressed to. So yeah, we started about 3.5 years ago, in a project for building an app for the astronauts, and that made us understand that the approach a developer has in building apps is not always true. It's not always, it got faulty somewhere because we try to, as developers, we try to assume and to make assumptions that what it works for us, it works for everybody. And we were struggling in the way to develop our apps for the astronaut. And so what we did, we're going to get back later on these slides. What we did, we opened up our software, and we called in all of the possible partners that could help us. And mainly of them, the most of them were from research scientists, were from psychologists, teams, departments, and they helped us, and we worked together in order to be able to, as I said to you, to change this perspective point of view as a developer. We were struggling in a way that we didn't really look at the empathy of the user. We didn't really look at the, okay, cool, result-oriented program. It works, everything was working, but it wasn't accessible to the users. So we stopped coding, really, literally, for 6 months. For 6 months, we didn't do anything. Actually, we forgot how to code after 6 months, but and we focused on our users. We focused on what our users' routines are, what our users' needs are, and that was really important for our research and for building our app. Our app was and is still in a prototype. It's going to go in space in 2020, next year, and our app has embedded machine learning inside, and that was one more step to complicate things. It wasn't like, you build an app and then you have the feedback of the user. Well, the feedback for astronauts is life or death, so you don't have a feedback from the user if your app is not working. And we start analyzing behavior of astronauts. We were lucky enough to be funded and sponsored by major companies. So we went to JFK Space Complex, and we did interviews with astronauts. And we saw that during missions they're doing on the ISS, astronauts are losing almost 15 kilos. And we didn't know that. We didn't know that when they are trying to touch something on the screen, their stress level goes high peak, and we didn't know that. We didn't know that they are inside almost like a cylinder with cables and their psychology. And we didn't know, well, for example, simple things. When you get out of your house and you leave your keys inside, you get panic. Well, at least I'm getting panic that I left my key and I don't know where I left my key. Imagine that your house is on microgravity, meaning that you leave your key on the table and it starts floating and it goes away. So you're getting panicked, you are inside the cylinder and you cannot open the window to take a fresh breath, because otherwise it gets sucked in space, and you're looking for your keys. So what you do? You get panicked a lot. So all these analyses and all these studies that we didn't make, they were like drain our developer team down and not be able to accomplishing what we were meant to. And later on I'm going to show you a couple of slides that are referring to the tasks of an astronaut. So we sat down and we start getting inspired by different technologies that are going on in different debates that are doing about user research and designing. And we stopped at Google Clips. I don't know if you ever heard about Google Clips. Google Clips is a little camera, and this is how little it is. And the really unique aspect is that it's built-in device. There's machine learning, meaning that there's no Wi-Fi, and it spins Wi-Fi inside in order to be able to transfer the content from the device onto your phone or on other devices. And this is what Google call it iLock. So we sat down and see the processes that Google did for going into producing this device. Those are some snapshots, snaps, some frames that the camera takes. And what it's important, the important thing is that they change the approach and the perspective from taking picture from a viewfinder into being a curator. We're going to go back later on that, on being a curator and actually being able to pick what we want without losing the moment we are into. So the Google Clip started with the objective for the user not to lose the moment by taking the picture and be inside that moment. And this is really important because how many times we are living a moment of our life and said, I wish I could have taken a picture of that moment, or I wish I could have impressed in my memory that moment. And yeah, it's not really handy. Wait a second, like the video before, it wasn't really handy. While if you had this Google Clip hanged somewhere, you could have taken the whole moments and then decide which is the best moment. That's nice. You're following me. That's good. Remember these things I'm saying you now as an excursus, because later on we're going to go a little bit in depth into those kind of user perceptions. Try to get out from your developer point of view and go into the user perceptions. So what we decided, we decided that the best important thing to do is to find the astronauts in our case, but the user needs, for fulfilling user needs. And that's really important when you're trying to build an app, or when you're working on a project. Because technology, it's really advanced, but if you misuse it, it might be against user wanting and needs. And well, fatally, on space, this is from gravity. In space, if you don't use correctly technology, as I said before, there's a life-death way. There's no, I don't like, there's no rating the app. There's, if I don't rate it, it means that I'm dead. And yep, so we need to find the astronaut needs. And how we did that? We studied Google Clips, as I told you before, and this is how the camera sees the patterns outside and try to taxonomy them on the back end, and gives you a really categorized pattern of what the camera took. It's a bit like, do you use Google Photos? Okay, it's a bit like Google Photos. Google Photos is almost the same thing. It's the Google Photos is the archive of what Google Clips did, and goes to the archives, and after the archives, it transfers into the data server. So what is the item that Google did with Clips is that you're the curator, and you are you as user, you are the one that chooses what he wants to see. And there is this flow of going offline and online. Not a lot of us like the idea that all of our data are online. We need as a human being, we have the need to belong to offline. We have the need to touch something. And that is the perception that Google Clips and Google Photos give to the user. It gives the perception of being offline, but be online. Be able to choose photos and not losing other photos. And now going back to the astronauts, and that's a little bit of parallelism I'm going to show you on the next slides. Those are, as you can see over here, those are night, days, night, night, light, night, light, night, light. So for, those are hours. So in 12 hours, you can see that you have 6 periods of dark. And that make you understand that the psychology of an astronaut is a little bit mixed up. Like over here, you go to sleep when it's dark and you wake up when it's day, when it's light. Over here, you sleep and you have 6 phases of day and light. Those are the tasks that they need to do. And an astronaut is not as much as, it's not as different as a normal employee. He has tasks to do, he needs to sleep, he needs to go to the gym. It's a normal user, but in a different environment. Tasks to deliver. And this is another awkward user interface for uploading the tasks and gives you cautions and warnings. This is pretty simple. It's communication status, meaning that I can talk to the mission control and the mission control can talk back to me. So what we try to do, we try to have all those informations in a really bad UX output, categorized throughout the, categorized throughout the eye of the camera. We didn't really use the Google Clips to categorize them, but we just assumed that the process that the camera on Google Clip will do for the images it was shooting at, and categorizing them would help a lot. So what we worked on guide the intelligence, meaning that we worked on not being used by the machine, but using the machine in order to be able to give a simple pattern of frames or of tasks that the astronauts were in need of. And of course, lots of questions came out. Say, how do we do that? How can we not assume? I don't like assumptions. How could we understand better? How can we make the machine understand the priority of the task? How can we make the machine understand what is next? And this is the most effortful task of UX or a developer. It's try to identify the link between the machine learning and ourselves. You know that if you are a web designer, if you are a mobile designer, or if you work in an architecture, you have to deal with W3C specs, you have to deal with touches, you have to deal with size of buttons, you have to deal with color of buttons. And all this made us understand that we are not trying to reinvent the wheel. We need to just adjust and adopt the wheel into our day-to-day tasks. So let's go back to the question that what's next task for the astronaut would like. We trained the model with some diagrams and some data sets from tasks over the last 10 years that the astronauts were doing on space or off space. And that looked a little bit crazy to understand it. It looked like, where the hell are we going to? What's behind all those little diagrams? And it was like devastating our team, trying to understand the meaning and the purpose of training a model, and the model giving us back some random data that we couldn't really apply on our application. So we went one step back again, and we did what we called a human-centered machine learning exercise. So we tried to lay back and step down a little bit and try to train the machine on what an expert is, not on the tasks. So who is the developer task is to deliver his job. It doesn't mean that he's an expert. He just delivered the job. So we try to go back and see that the tasks were done by experts and not that the whole process was expert. So we, and this is real, we really hired clock engineers, clock manufacturers. Why? Why we hire them? Because the clock, D per se, has a few mechanisms that gives you what a clock does. Thank you. What a clock does? It tells. It doesn't measure. It tells time. Yeah. And time is, for everybody, is a common sense. So if it's 2 o'clock for me, it's 2 o'clock for you. Well, you change time zone, yes, but if you have a point of reference, 2 o'clock is for everybody, let's say that. We're going to go later on these about the redundancy and continuity of time. So we gave, we hired clock engineers and clock manufacturer to help us create data sets to be able to train the model. We came out that the common sense is it's really easy for a human to adopt a common sense. If it's good, it's good. If it's bad, it's bad. Now, there's a lot of gray zones in bad and good, but if you talk to a machine and you see the algorithm and the results, bad, good, 93%, 92% is a common sense. Low data set and less time, we can really come out with the ultimate good and bad distinctions. While I don't know if you ever seen the TensorFlow, that the neural networks about the cat and the dog, you got so many layers and weight of layers before coming out saying that this is a cat and this is a dog. And we're not even talking about the race, the type of cat or dog. So we redefined and realigned all our researchers into those two dogmas, we call that manifesto for us. So what specific predictions need to get trained and what can the model confidentially ignore? Going back to the clock engineer, we did that because if you see a clock, got a bunch of tools and mechanisms that are not used to tell you the time. You just need 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say 12 to 15 mechanisms to tell you the time. So what we did, we trained with a set of data set, the machine into focusing on what makes the clock tell you the time, and not all the other mechanisms. So we didn't train the machine in what this is for, what this is for. We trained the machine to say that you need this in order to tell you the time. And if the machine was telling you the time, it meant that I was an expert clock. Why I'm saying you that? I'm saying you that because you're cutting time on learning the machine and training the model on what is a common sense for everybody, instead of training the machine on all these bits and balls that eventually comes out that it's going to tell you the time. So we said to the machine to ignore all these mechanisms that are not useful, to tell you the time. Translated into astronauts and our app, we set the machine to ignore all the tasks that weren't supposed to be and to focus on accomplished tasks in order to be able to predict the next task and what was going to be wrong. So we trained the machine to understand, once it understood the mechanism, to understand how it works. And then continuity. We train the machine about continuity, latency, and redundancy. If I'm asking you what you understand from this image, I think it's pretty clear that it's a clock. While this image, it could be a clock, but it could be also a chronometer, could be a stop timer, could be an alarm clock. So these are too much information for the machine to understand. And too much information for the machine to understand, it means that it takes way too much time to give you results. You have to invest a lot of money in order to be able to keep it up with your research. While if you stop clock, it comes out, and I'm telling you from our experiences that it comes out that the 95, 96% of the results on tasks were almost 100% accurately. Redundancy. Redundancy, again, we focused on clocks. And we thought about we thought that in an hour you have 60 as a redundant number. You have 60 seconds, you have 60 minutes, and then you have 1 hour. Meaning that we were training the machine to understand the difference, which means diversity, of a second, hour, and minute, but to understand that they are somehow linked and their legacy together, redundancy, that a compound of 60 makes 1, a compound of 1 is made by 60. And we clarify the machine with a set of data set that this is important for you, machine, to understand that as a unit of measurement, you have 1, but then you have 60, and then you have 1 again. It's a bit complicated or not? Okay? So doing that, what we did, and all those results we were sharing it with the astronauts, and we were sharing with Mission Control Base Center at NASA. We were trying to build trust in humans, that using machine learning and artificial intelligence is not that thing that they used to say, that thing knows more than we do. Sorry, it's not a thing. Machine learning and artificial intelligence, it's a compound of processes instructed by us. They're not yet instructed by themselves. And we give them data and the procedures on how to do that, and they just do their job. Artificial intelligence just doing its job, accelerating predictions. It doesn't do anything. Super wow sci-fi. And then we come out with our first fundamental, that perfection isn't possible. It shouldn't be the goal. So you don't need to be perfect. Machine learning is not bug-free. We use it as a technology simply, as I said, because it is able to make prediction faster than we do. But it makes mistakes. And imagine that, I don't know, you have a client or you have a partner, and then you say that you're going to use in your app AI or machine learning, and you won't have any margin of error. And suddenly, the prediction or the result is faulty. You lost the partner, you lost your client. So let's try not to build up on bias about artificial intelligence, at least at our stage. Now, myself included. There are some other experiments that the machine and the artificial intelligence goes beyond human capabilities, but that's not the case yet. And it happens once, twice a while. For example, I don't know if you heard about the Stargate, that they put the artificial intelligence to play with Stargate and eliminated all the humans, which is not really helpful, but it's an example. So we're not still yet. We're not yet there. We're not talking about Terminator coming and killing us all. And Terminator was programmed. So artificial intelligence is programmed. I'm saying you that despite your enthusiasm to learn more about artificial intelligence, I'm saying you that because you need to be able to cover up yourself. So one thing is if you approach artificial intelligence as a student, as a researcher, yeah, you can go and have no limits. But if you're approaching it as a developer, you need to understand that you have limits. And those limits, you need to be able to promote, sell it to your customer, to your client, to your partner. You need to base yourself on what you or your team is able to do. And using the technology, not selling the technology that you're using. And that's the second fundamental, that AI shouldn't find the needle. It should clear the way to highway. Meaning that the AI, you cannot train a model to find something somewhere. You can train the model to show you the way to find what you want. And this is simple mathematics, like 1 + 1 is 2. It's, if I don't put the 1, the 2 ones, I'm not having the 2. So I cannot say 1 plus, tell me the results. The artificial intelligence will give you, it will give you back a set of numbers that can go from 0 to loop infinity. So, really? That's the first time I'm on time. Usually I'm taking 10, 15 minutes to finish I'm finished. On a graphic point of view, on a designer, point of view, you need to address human needs in order to be able to embed machine learning and artificial intelligence into your project or into your app. You need to uphold human values, meaning that you need to focus on human values in order to be able to understand artificial intelligence. And you need to design for augmentation. I'm just going to do a little example on when, artificial intelligence and machine learning, it's like in our childhood when we were going to school, they didn't say to us, this is how you read. They gave us a bunch of phonetical, let's say, arrays. They gave us some examples and they say to us, connect them and try to read. So this is artificial intelligence. This is machine learning. Machine learning has got hunches. It's got it hunches predictions. It's like a little child. Time's up. That's okay. It's like a little child, and it makes error, and it's faulty. It's on its first stage of life. So don't try to impress or get impressed by somebody who says to you that artificial intelligence is here for replace us. Again, I'm saying to you, not yet. There's a study that, got still a couple of minutes. There's a study that we are actually doing that, you know what's the main difference between human and machine? Just a couple of inches, go ahead. Throw it.
One can pass the Turing test, the other cannot.
That's a good one, but not really. Nothing? Try it.
Flesh and bone. Flesh and bone.
Not yet. Nah. Machine can build tissues that look like flesh and bones. Now you saw some random poems that machine did. I don't know if you ever heard about the machine writing a poem. So it's not really empathy, but it goes there. It's going there. Culture, well, it's debatable. Yes and no. It's more common. We talked it earlier, and that's why I'm obsessed with cloth.
Common sense?
No.
Self-organization.
No.
Creativity?
No, they're more creative than humans sometimes. Didn't say that. Time. We have time issues. We were experiment we did, and the machine got back to us saying, because the only problem nowadays with the machine is that they're not self-sustainable. They need to be plugged. So if you unplug them, the battery drains away. And it founds by itself an algorithm that collects energy from exchange of bits. So it replies to us and said to us that, you know what's your problem, the machine to the human, that you're going to die. I'm not going to die. I can collect energy, and after 1,000 years, I can wake up, but you're not going to be here. So that's the difference between human and machines. But that's a debate that it's not the case to do now. And I think time's up. 1 minute. Okay, I'm going to show you at least what we did for the astronauts. So this was the early mock-up. And you can see that it was invasive a lot for the astronauts, right? Red, black. Here, your hand shows that you're doing something wrong. Over here, it reminds you a lot of Earth nostalgia. And this is what we came out from. Meaning that you have black background, you have earthy color, giving the astronauts the ease that is like being home. Water, sea, trees, and it's user-friendly a lot. And there's other bunches of prediction of exercise that they were doing. We are using plants, but this is another story. So that was from me. Thank you. If you want to know more, please go inside here, the library, and you get a lot of fundamentals and concepts about machine learning, artificial intelligence, how to create apps. Thank you.